Hi, welcome to our first video for 7.2 compound interest. So compound interest is a little bit more exciting than simple interest. So simple interest look like an arithmetic series or sequence. So let's say if we started with $1,000 in our account, okay, and let's say we made 10% simple interest, we would make $100 off that initial investment. 10% of 1,000 is 100. So we would say we would add 100 to this and we would get 1,100. And every year we would earn that 10% off the principal, the initial principal. So we would get another 100 and we would then be at $1,200. And the year after we would add another 100 and we'd be at $1,300. You get the idea. Kind of boring. That's why it's called simple interest. Okay. What's more exciting is compound interest. So the way how compound interest works is we take our principal amount, let's say it's 1,000. Let's say we make 10% interest. So when we're talking about compound interest, we use the symbol I. Okay, when we're talking about simple interest, we use the symbol R. Interest works the same way. We should always express them as a decimal. But I lets you know that you're working with compound interest. So the first year, our principal was 1,000. Then after 1 year, we're going to make 10% off of that. So what we're going to do is we're actually, this time around, we're going to be multiplying by 1 plus the interest rate, okay, which is going to be 1 plus the interest rate. So if I were to write this as a decimal, it would be 0.1. So 1 plus I is going to be equal to 1 plus 0.1, 1.1. Okay. So we're multiplying by 1.1, and we're going to get, if I were to take 1,000 and multiply it by 1.1, I would get 1,100. Okay, no different than simple interest for the first year. However, what makes compound interest special is that I'm not going to keep making interest off the initial principal like we did with simple. I get to take this as my new principal for the next year. So I'm going to multiply this one. Oh, try to get the same color. Okay, I'm going to take that term and I'm going to multiply that by another 1 plus I. Okay, which is just 1.1. So if I do that on my calculator, I believe it works out to like 1,220. So 1,100 times 1.1, 1,210. Good thing I checked. Okay, so 1,210. And then for the next year, this is my new principal. So I'm going to multiply that by my new interest rate. So I'll multiply that again by another 1 plus I. So this time I take the 1,210 and I multiply that by 1.1. Okay, 1,331. So you can see that this is growing a little bit faster than simple interest. So at the end of the third year, so this is the first term, and then at the end of the first term, so at the start of the second year, we'd have 1,100, 1,200. So start of the fourth year, we have 1,300, or at the end of the third year. Okay, so we made an extra 31 that we wouldn't have made in the simple interest. So that doesn't sound like much, but notice this is growing though. Like every time we get to multiply by another 1 plus I, that principal is getting bigger and it's growing quicker and quicker. You can see this is a lot like a recursion formula. Okay, so simple interest this year, I would, for that end of that fourth year, I would have 1461. If I just fill that in, sorry, I would have 1460 because it only 1400 because it only goes up 100 each time. So I'm actually made an extra $61. So it doesn't seem like much over a little bit of time, but if we allow this to keep compounding for 10 years or 20 years, it can actually grow quite large. If you're wondering why I was multiplying by 1 plus I for this, it's because the reason why I do 1 plus I is because I need to keep the initial amount, and then I need to add on to it the interest that I make off of this. So this might help a little bit to look at it this way. If I take that 1,000 and I multiply it by 1 plus I, if I distribute this in, you can see I have my initial amount 1,000 from doing that times the 1. And then I also get plus the 1,000 times the interest rate as a decimal. So this number is not really big, right? Because it's like 0.1 times 1,000. So 1,000 times 0.1, that's only 100. Okay, but you can see how doing 1 plus I really helps you to find that new amount at the end of the year. So, and this is for compound interest, this is my new principal. So I'm going to multiply this by 1 plus I again, and I get to do that every year. I get to keep multiplying by another 1 plus I, and it keeps growing and growing. That's what makes compound interest so special. So simple interest, I'm just going to add here. It's a lot like an arithmetic sequence, okay, because it has a common difference. Okay, whereas compound interest is definitely a geometric sequence. It has a common ratio. Okay, that common ratio is always 1 plus the interest rate. That's what we multiply by to get the next or the new amount. Okay. How often do we multiply by 1 plus I? We do it every compounding period. Okay. So I'm just going to read through these definitions real quick. So compound interest, it's interest that is calculated at regular compounding periods. Okay, it's added to the principal. That's why we do the 1 plus I. It's added to the principal for the following compounding period. So the principal grows each year. The compounding period, well, it depends on what the question gives you. The compounding period refers to the time interval after which compound interest is calculated. So if you're told in the question that it's every year, it compounds every year, then that means the principal is going to grow every year. We're going to add the interest to it. If it's compounded monthly, then the interest is added every month to the principal. And then you make interest off that new amount. So as you can tell maybe from what I'm saying, you might realize, hey, it's actually better for investments to have more frequent compounding periods because that interest is added on earlier and then you make interest off that new amount. Anyway, I hope this isn't confusing or nothing, but we're going to get ready to do the first example. There's just one more thing I want to look at, or show you, and it's going to help us come up with a formula that's going to be really easy to use. So I'm still talking about compound interest, so I'm going to write this out a little more algebraically. So see how I gave you an example here with 1,000? Well, what I'm going to do is I'm just going to say that initial amount, and I'm going to call it P. So I'm just going to write down here for now. So P is the principal, and then in order to find how much I have at the end of the year, I need to multiply this by 1 plus I. So this is like my first term in the sequence. Okay, this is how much I have at the end of the first year, so that's my first term. How much do I have in account the year after that? Well, I'm going to take my previous amount and I'm going to multiply it by 1 plus I. So I'm now going to have P times 1 plus I times another 1 plus I. Well, I know I can just write that as 1 plus I squared. And then we're going to do it again for the next compounding period. Multiply by 1 plus I again. So now it's going to be P 1 plus I cubed. And as you might have guessed, we're going to do this for up until the nth term or the nth year. So we could say nth compounding period. So how much am I going to have in the account? Well, I'm going to have this amount right here. Okay, that's how much I'm going to have at the very end. Okay, because I'm each time I'm multiplying it by the old principal plus the interest rate, so that is how much the account is growing. So there we have it. That's our formula. We can say the amount in the account is going to be the principal times 1 plus I to the exponent n. Okay, I is always the compound interest. Compound interest rate. Okay, and it's always expressed per compounding period. So it's the compound interest rate, and I'm going to say per compounding period. Okay, and then the end represents the number of compounding periods, so the total amount. Okay, and P is obviously the principal. And A is the amount. So that's our special, let's include everything here. That's our compound interest formula. This is how we can calculate the total amount that we earned on an investment, or even the total amount that we're going to pay for borrowing money. Okay. All right, let's go ahead and see if we can use this in the first example. So it says calculate compound interest. So this is actually quite simple. So it says to buy a new guitar, Gaston borrows $650, which he plans to repay in 5 years. So the bank charges 12% per annum. That's another word for a year. Compounded annually. So also means yearly. So this is great because these are on the same frequency. Okay, the interest rate is per year, and it compounds every year. So this is actually really nice. These always need to be on the same frequency. Okay, you can't give me a weekly interest rate that compounds every year. It doesn't work like that. They have to match. So either this is per month and this is monthly, or this is per year and this is yearly. Anyway, let's write out what we're given. So that's $650. That's the initial amount borrowed. And the interest rate is 12%. I got to write that as a decimal, 0.12. The number of compounding periods. Okay, well, it's compounded once a year and for 5 years. So just 5. Okay, determine the amount that Gaston must repay. They want to know the amount. All right, so that's easy. The amount is equal to the principal times 1 plus I to the exponent n. Principal is 650. Multiply that by 1 plus 0.12 to the exponent 5. Okay. The banks are always really greedy. 12% per year. Okay, compounded annually. The compounding part's not too bad, but the 12% per year, that is quite high. All right, so at the end of all this, Gaston is going to have to pay back. So 1 plus 0.12 is just 1.12. We can just add that in our heads and put it in the calculator to the exponent 5. Okay. He ends up paying the bank back $1,100 and $1,145.52. So almost double what the guitar was worth. And he pays that over a period of 5 years. So maybe Gaston pays monthly So they divide that total up by 60, and that's his monthly payment. All right. So if you're going to borrow money from the bank, this is the moral of the story. If you're going to borrow money from the bank, use it to buy an asset, something that's going to go up in value. Okay. So unless you got Steve Vai's electric guitar or something, you probably don't want to borrow money to buy a guitar. All right. Part B. How much interest will Gaston have to pay? So how much interest does he pay? Well, that interest, we can easily find it. We can take the amount that he paid and then subtract the principal from it. Okay, the initial amount that he borrowed. So 1145.52 minus 650. $495.52. So that's a lot of interest. Compare this to the amount of interest he would have to pay if the bank charged simple interest. So usually banks don't charge simple interest because they know that people don't really understand compound interest and they'd rather take more of your money. So if this was simple interest, okay, the interest is equal to the principal times the rate times time. Okay, remember PERT? I kind of said that before. It's an easy way to remember. So 650, the 12% is per annum, so it'll be 0.12 over 5 years. 650 times 0.12 times 5. $390. So that's quite a significant difference between the compounded and simple interest. So if you're going to borrow from the bank, try to do simple interest. If you're going to do an investment, you probably want to take a compounding approach. All right, that's it for our first example. Hope you found this helpful and maybe interesting too. And I'll see you guys in the second example.